In this problem, we want to find the equation that's traced out by a point that moves as a sum of the distances of the points 0, 0, and 0, 4 is equal to 12. So I'm going to go ahead and just get a picture of this going because um, I don't know about you, but I tend to imagine understand things better when I kind of have a clear picture of what's going on here. Okay. So we have our one point here at the origin. This is 0, 0. Call that point O. And then we have another point. I guess I could draw that a little bit better, but another point here at 0, 4. And call that point, I don't know, P. Okay. And so there's some point out here. And it looks like we're looking at the distance between them as something like this. Okay. So if I call this D1 and this one D2, this has values or points X, Y. And this is going to be my point P, I guess Q. Okay, so Q has the point or the coordinates X, Y. And so what it's saying is that D1 plus D2 has got to equal 12. In other words, as I move this point around, however it traces out, okay, it's going to trace out a path uh, and the sum of it, such that the sum of the two distances is always equal to 12. Okay. So using coordinate geometry, very similar to the last problem, actually. We're just going to set up. So D1 is equal to, I'm going to talk about D1 squared first, because the squares are easier to deal with. The differences in the x's here are going to be x minus 0 squared plus y minus 0 squared. So that's going to be the distance. That's a 4. Sorry, it should be a 4. Uh, so that's the distance between this point at any position and that fixed point there. Okay. And then D2 is going to give us the difference between this point and the origin. So this is x minus 0, 0 squared plus y minus 0 squared, which will give us what you would expect squared, uh, which is really just x squared plus y squared. Okay. All right. So we're going to take the square root of these distances and plug them in here and then see what we can uh, find for the equation of that traced out. Okay. All right, so we have the square root then. This one is going to be x squared because of the minus 0 plus y minus 4 squared. So that's d1 plus, here's d1 plus the square root of x squared plus y squared. And that sum has to equal 12. Okay. All right, so it looks like at this point we have two square roots. So in order to simplify this or to put it into some sort of form, we're going to have to do a couple of squares. So it doesn't matter which one you choose to. Since this is the furthest, I'm just going to subtract that term over, and then I'll square this, and I'll square both sides. Okay, so I'm going to subtract over this term right here from both sides. So I'll write that out first. So it's going to be the square root of x squared plus y minus 4 squared is equal to 12 minus the square root of x squared plus y squared. Okay. And then now that I have that factored out, I'm going to square both sides to get rid of the square root. Okay. Okay. So doing that, the square root and the square are going to cancel each other out. So I get x squared plus y minus 4 quantity squared is equal to, and then now I have to FOIL this out. Okay. So if you recall, if I can do it up here, something a minus b squared, okay, is the same thing as if I multiply this out, a squared minus 2ab plus b squared. Okay, so if I think of a as the 12 and b as everything under the square root, it may help to simplify out, multiplying this out. So I'm going to get 12 squared. That's the a term square. Okay. Okay, so I get 12 squared. And then I'm going to have minus 2ab, so 2 times 12 times the square root of x squared plus y squared. Okay, so that's the second term. That's b. And then plus b squared, which is, we're going to write b squared, plus b squared, which is going to be x squared plus y squared. Okay. All right. It looks like that's an x squared here. Okay, it looks like I'm gonna have to square one more time for this term. And so I'm gonna kind of expand things out and group things together to see if I can get something a little bit nicer. Okay, so hopefully some things will cancel out, and that'll make things a little bit nicer. So I'm gonna have x squared plus y squared. So I'm doing the same thing here. I'm foiling this out using the exact same relationship up here. Okay, so it's gonna be y squared. That's the a term, and now minus 2 times 4 times y plus 4 squared. Okay, so that's the same exact relationship here. So you can see that's very helpful to kind of have that in multiplying these out. Okay, and so 12 squared is 144, and then this is minus 24, 2 times 12, square roots of x squared plus y squared plus x squared plus y squared. Okay, so here you'll notice that this is 16 and this is 8. I have an x squared on this side and an x squared on this side. So if I subtract x squared from this side, these are gonna cancel out. And if I subtract a y squared from a y squared, those terms are gonna cancel out, which is really nice. That'll simplify things nicely. And then here, this is gonna be negative 8y plus 16 is equal to 144 minus 24 square roots of x squared plus y squared. Okay, so I'm gonna move everything with a square root onto this side and move everything that doesn't involve that over to this side. So subtracting 16 from both sides, that's gonna give me 0. This is gonna give me, um, let's see, that's gonna be 14 minus 6, so 8, and 13 minus 1 is 12. Okay, so it's going to be 128 plus 8y, adding 8y to both sides. Okay, and then I'm going to add the 24 over to the side. So I get 24 square roots of x squared plus y squared. Okay, so I've just moved it over here by adding this term to both sides, equals 128 plus 8y. Okay. Now I notice that um, at least a 2 goes into each of these terms. So I can at least divide by 2, but I'm going to divide everything by that 24. Okay. Um, I don't know if 24 goes into 128. I thinking that would be a good calculation to do, but I don't think it goes in evenly. So if we do reduce it by 4 at least, I know 4 will go into 12. You see the 12 right there? So that'll go in 3 times. And then 12 goes into that 2 times. And then 4 goes into that. Wait, is that right? 128 divided by 4 is 3. And then 2. So that's 32. Yeah. And then 4 goes into 24 6 times. Okay. And then 8 goes into that once, and 8 goes into that 3 times. Okay. All right. So it does simplify quite a bit, which is nice. Those numbers are much nicer looking than that. So we have the square root of x squared plus y squared is equal to 32 over 6 plus y over 3. Okay. That's good. And now I'm going to square all of this. Okay. And so those are going to cancel out. So you're going to get with x squared plus y squared equals. And now all you have to do is multiply this out I should note that I could pull out a 1/3. Is that the best use of that time? No. Yeah, and no, we'll just multiply it out. So let's just do this. 32 over 6 plus y over 2 over 3. So we get 32 over 6. I'm just going to leave that as 32 over 6 squared for now. And then let's see. I guess I could reduce that again, huh? Didn't think about that. Anyway, so plus 2 times 32 over 6 times y over 3 plus y over 3 squared. Okay. All right. So this is following the same result as above. Okay. Some cool things happens here. This is over 3, and so what is this reduced to? 2, it's a 3, and that would make that 16, so it's 16 thirds. Okay. And then we need to square that, so I'll leave that for a second. This reduces 2, so this is 32 over 3, and this is going to be y squared over 9. So we have this whole term right here is 32y over 9. That's a 9 plus y squared over 9. So they have the same denominator. So I'm going to subtract that over to this side. And so I get y squared plus, I'm going to make this y squared 9y squared over 9. If I put this over 1, since I'm going to be subtracting this 9y squared here, I want a common denominator. So that's like multiplying it by top and bottom by 9. So that makes it 9 over 9. Just sorry if you couldn't see what I was doing there. Sorry about that. So this is, I want this to be the same denominator. So when I subtract this over, so I'm going to subtract y squared over 9 minus 32y over 9. So I'm subtracting that from this side, and I'm also going to subtract from this side. So minus y squared over 9 minus 32y over 9. Okay, and that's going to equal 16 squared is equal to, well, it's equal to 16 times 16. So 36, 6, 7, 8, 9. That's a 6, and that's a 1, so that's 6. It looks like a 5, 256 over 9. So this is 256 over 9. Okay. All right. And so we have 9 over 9 minus 1/9. So we're going to have running out of room. So I'm going to kind of ironically go back up here. This is going to be x squared plus 9 minus 1 is going to give me 8y squared minus 32y. And since they all have a common denominator of 9, I'm just going to write it over 9 now. So, and this is going to equal this crazy thing over here, 256 over 9. Okay. All right. And then notice that here we have a common denominator of, or common factor of 8 I can pull out. It's going to be x squared plus 4 over 9. And I have y minus 4, y squared over minus 4y. Okay. Equals 256 over 9. Okay. So this is almost in the right form now that we can put it into something useful. So I'm gonna take this and write it on the back side over here. And so I have x squared plus 4/9 y. No, that was 8. Is it 8/9? Yeah, that should be an 8. Sorry, I pulled out an 8. That's where the 4 comes from. 8/9 y squared minus 4y equals 256 over 9. Okay. So now I'm gonna use completing the square here to to simplify this, to put it into a form that maybe a little bit more recognizable. I can tell you what it is now, but I think it'll be worthwhile doing. Um, so to do this, I'll do it separately, and then we'll come back and deal with the factor out here in just a second. So y squared minus 4y. To complete the square, you take half of the b term, and so we're going to have 4 divided by 2, and then you're going to square it. But to do that without changing the value of this entire thing, I also need to subtract the same thing that I'm adding. So 4 over 2 squared. Now, I know that 4 divided by 2 is 2, but I wanted to show you that it doesn't matter what this coefficient is. You can do the same process. Okay, so you're going to get 4 over 2, which is 2 squared, and you're going to add and subtract that. So this is equal to y squared minus 4y plus 4 minus 4. Now, this right here is a perfect square. It's y minus 4 quantity squared. And if you multiplied this whole term out, you would get exactly that. Okay. So this thing right here, ignoring that for a second, is going to be this minus that. Okay. Minus that. Okay. So this whole thing is equivalent to this. Okay. So let's go back up to this and now worry about that. So we have x squared plus 8 over 9. And then I have y minus 4, quantity squared, minus 4 equals 256 over 9. Okay. And so now look what happens. I'm going to multiply this 8/9 here, but I'm also going to multiply it by that. And then I'm going to add that product over to the side. Okay. So that's not all at one step, but that's what I'm doing. So I'm distributing this thing. So I get x squared plus 8 over 9, y minus 4, quantity squared, plus 8 times 4 is 32 over 9. That's a minus, sorry. The minus from here equals 256 over 9. Okay. And so now to put this in a little bit more form, I'm going to add this term to both sides. Okay. Those add to 0. And so we have x squared plus 8/9 y minus 4 squared is equal to, adding these together, I get 2 plus 6 is 8. 3 plus 5 is 8. So this is 288 over 9. Okay. And let's see. I'm going to multiply everything through now by 9. So 288 over 9. So if I multiply everything through by 9, I'm just going to do that to simplify things real quick. So this is going to be 9x squared plus 8 y minus 4, that's a 4 squared equals 288. Okay. And now if I divide everything through by 288, 288, 288, okay, and do a little bit of an algebra manipulation here, I would get that this is x squared over 288 divided by 9 plus y minus 4 squared over 288 divided by 8, which could simplify, is equal to 1. Okay. And so in its final form, we get that this is the equation of an ellipse, which is what you should expect. So that's the conic section of this that's curved with the fixed foci length summing to 12. That this is exactly what we would expect from that result. Okay. All right. Notice we could simplify this a little bit, but for now, I think that video is long enough. I hope this was helpful, and I'll see you in the next video. So I was looking at this and I wasn't happy with something was bothering me. What I realized is that back up here, when I was completing the square, when I finally wrote it in its factored form, so this part right here, when you write it in this form, it should be the b over 2 term. So this should actually be just y minus 2. So the only thing that affects is that it changes, each of these should be a y minus 2, y minus 2. That's a 2, not a 4, so it's y minus 2. And the final result here is a y minus 2. So just a clarification on that mistake there. So when we write it in the factored form, remember it's the b over 2 term, not the 4 in there. Okay. So that then is that is still the equation of the ellipse, and it's an ellipse opening in this direction, in the y direction, along the major axis there, and it's been shifted up by that amount. Okay. All right. Sorry about and I hope that was clear. If you were noticing that earlier, and you're like, hey, that's a really good point. So I just want to clarify that before we end. Okay. Hope that was helpful, and I'll see you in the next video. All right. Just to wrap this up, just in case you were unconvinced, let's go ahead and plot that equation for our ellipse. So I have 288 divided by 9 plus we have y minus 2 squared divided by 288, oops, divided by 8, and that equation equals 1. Okay, so that's looking pretty good. Let's make sure that our focus is our 2 points should be what we're given. So if you look here, A has the coordinates 0, 0, and B has the coordinates 0, 4. Those are our foci. That's exactly what we're looking for. Okay, let's create a point on the object. There it is. Okay. And now we're going to name 2 segments from B to C, the point on the object, and then a segment from C to A, the other foci. Okay, and if you look at F, the distance x plus G, that equals 12. That's a good sign. And then if I, make sure I'm moving, if I move C around, no matter where I go, you'll see that A, so let's say text, the distance is of F plus G is A. Okay. So there is, oh, let me F plus G equals. Okay. So as I move point C around, you'll notice this should stay constant if we have the correct equation. So here we are moving those around, and you can see over here the length of the segments are changing. But indeed, that is a constant value of 12. So we have, in fact, the correct equation of the ellipse for this problem, given these foci, and the sum of the 2 lengths is, in fact, 12. All right. Now, I hope that was helpful, and see you in the next video.